All right, let's do this. So in this one, this example, we're going to be figuring out the least common multiple given two integers, positive integers. So let me just put a proof here. So I need to write this down just so I have it. So we want to compute the least common multiple, right, given two positive integers, right? And of course, it's all about speed. So we have to do this the fastest, best way possible, efficient algorithms. So considering how I figured out the greatest common divisor, I think this will be somewhat the same way. So for example, if you have like a sample input, oops, man, I can't type today, of say 6 and 8, you should have something like 24 as your output, right? So I was writing on a whiteboard, just trying to figure it out. And the thing I came up with basically we want to take the A times B, so the first integer times the second integer, and I want to divide that by the greatest common divisor, right, of A and B, right? So in this case, it'll be for 6 and 8, the greatest common divisor will be 2. So say we'll multiply 6 and 8, and we should get 48, divide that by 2, we'll get 24. And that should be consistent with any integer that we give, as long as we know the greatest common divisor. So first things first, we need to gotta import our java.util and scanner. Yeah. And there's gonna be public class, what is this, least common multiple. Yeah. All right. So in this case, we're going to create a function just to get the greatest common divisor. So I'm just going to call static. It's going to be static long, and then call it get GCD. So I'm going to have two integers, not long integers, I guess. Call A and B. And of course, we need to verify. We'll make sure that it's not 0, because if it's 0, we can't do anything with that. So in this case, and this is really similar to how you would actually get the greatest common divisor. What I realized is a lot of this stuff, you're just building out tools that you would combine with other tools to solve different problems. Didn't think that least common multiple would use something like this, but yeah, create tools to use tools. Right, in this case, we want to return 0. And of course, we want to have our remainder as we did before. I don't want that to be a long integer because it shouldn't. But we will need to cast it to an int. And of course, do the same thing that we did to get the in the last video, where we divide 8 or A, well, modulo. We'll use A modulus divisor B. I don't know how to say that. Get the remainder of the A and B. There you go. Using a modulus operator. Booyah. Anyway, and of course, if the remainder is not 0, of course, then we can recursively return get GCD, and instead of B, we're going to use remainder. Again, this is the Euclid's algorithm, where you would recursively put in the remainder, or I guess the prime of what A would be in this case. A prime, yeah, also remainder of that. So anyway, else we would return B. All right, so pretty straightforward. Again, this is similar from what was done in the last video, just changed up the variable names. I'm typing this again just to get it under my belt, because again, this is learning for me, actually. Yeah. All right. So now onto our main method. Oops. Yeah, and again, I'm just typing this out just to build muscle memory with this stuff, because you just got to know it. Just got to know it. We don't have to recreate the wheel anymore, but it is a lot of research, just understanding all these algorithms people spent time creating. Anyway, so we scan, or input in this case, scanner. I like saying input because it's, I don't like scan. I've seen a lot of examples use that. All right, A equals input, yeah, dot next long. And same thing with B. I like to keep the variables consistent so I know where they will go. They're just good naming conventions. All right, so now in this case, I do want to have a variable for the actual GCD because we need to address if it's 0. Yeah, so if it is 0, we have to do something with that. So as if GCD is not 0, then we can go ahead and handle business. We can just print out the result, which would be, oh, should I create one for, no, you know what, let's create a variable for the LCM. That's because I don't want to do that all on a print statement. I feel like that'll make it confusing. So real quick, LCM, yeah, let's get some good labeling there. Okay, so in this case, again, we're going to do, going back to what the proof is here. So we're just taking our inputs, multiplying them. So A times B, and we want to divide that by GCD. Simple as that. We already calculated here, so we don't need to do it again. And if it is 0, then we want to just print that out. Yeah, D, yeah. Anyway, all right, so I don't know why it did that. I hate when it, did I do that right? Oh, capital J. Oops, all right. Man, spelling is all the way off today. There we go. All right, so then let's run and see if it works. So in our example, we have 6, 8, 24. All right. Here's another one too. 5 and 10. Yeah. And let's do 0 and 14. 0. Let's do 7 and 14. 7 and 14. 14, yeah. Okay, let's take a stupid long number. What's that example? No. Okay. This is do 2, 8, 8, 5, 1, 5, 3, 8, and then 1, 1, 8, 3, 0, 1, 9. Right, let's see. We should get some stupid number. Yay! What is it? 1,933,053,046. Booyah! That's correct. Yay! So this is it. This was actually pretty fun. I had to do something on the whiteboard with this, just figuring it out. And it's cool because my daughter's learning fractions and stuff like this. So yeah, it's like now I actually have an understanding of how it works out instead of having to go number by number. There's an actual formula to quickly do this, even in, without doing it on a program. Writing it out would be easier as well, doing it this way. So, all right, on to the next one.